Hello, welcome back. We are interested in finding the depth of a node in a tree. Right. First, let's write the definition of a depth of a node. What is the depth of a node? What is the answer? What is the depth of a root? So this, what I'm going to introduce now is an inductive definition. This is something you often notice in mathematics, uh, an inductive definition of some property. So here I want to define the depth of a vertex or a node, and I'm going to define this inductively, right? And here is the thing: what is the depth of a root? So inductive definition of, let me note this thing down. It consists of an inductive definition consists of two parts. One is the base case. So I'm writing depth of a node V. Okay, and depth of a node V is consists of two parts. It's zero if, when is it zero? That's the base case. If V is the root. If V is the root node, we know the depth of V is 0. Good. If V is not the root, what is the depth of V? It is 1 plus it's 1 plus parent of V. Okay. So if V is not the root, so that is why I have written otherwise. Depth of V is equal to 1 plus the depth of parent of V. Right? So it's 1 plus depth of parent of V. Let me just write down the depth of at every node. So here, this is what's the depth at A? 0. Depth at A is 0. Depth at B is 1. C is 1. D is 2. E is 2. F is 2. Sorry, F is 3. Is that correct? Yeah. And now look at our inductive definition. Does this satisfy the inductive definition? The depth of A is 0, right? Because A is the root node. That's correct. Depth of B, that is 1 plus depth of the parent of B. That's 1 plus depth of A, which is 1. 1 again, depth of C is, this is 1 plus depth of A. That is 1 plus 0, 1. Depth of E is 1 plus depth of C. That is 2. Similarly, depth of F is 1 plus depth of E. That becomes 3. So our inductive definition is correct. You all agree with it? Right. Now, once I have this inductive definition, can you convert this into an algorithm to do this? Do you see a particular kind of algorithm? Do you see a recursive algorithm for this? Yeah, you should see it. There's a clear recursive, because what I have defined is a recursive way to find out the depth of a node. And once I have this definition, I should be able to write a C program to find out the depth recursively. So let's write that algorithm. Okay, so depth of a node V. What is depth of a vertex V? The way we have written recursive functions is that we are going to first write the base case. Right? We are going to write the base case first. It's not required that you write the base case first, but that's the best practice we are going to follow, right? So what is a base case? The base case is if v is a root node. If v is a root node, what do you do? Return 0. Clearly, this is good. This is correct. Now, v is not a root. What do we do in this case? We return the we return 1 plus the depth of its parent. Is that clear? So it's a very simple recursive algorithm to so simple recursive algorithm to find the depth of a node. Right. So let's now we can look at another algorithm now. Finding the height of a node. We are interested in finding the height of a node. First, let's give an inductive definition for height of a node. What is height of a node V going to be? It's 0 if V is a leaf. Now V is not a leaf. What is the answer? It's 1 plus max over height of its children. Okay, so go through all the heights of its children and take the maximum value of it and add 1. That's height of V. Good. Let's write a function for this again. Okay, here is our algorithm to find out the height of a node, height of a vertex p. Now, first thing we do is, so again, this is a recursive algorithm. And what is the first thing we do? We write the base case. And the base case is, if v is a leaf, we are going to return 0 because that's the height of a leaf. Now, next thing we want to do is we want to iterate over all the children of this vertex and find out the heights of all its children and return the max of it. Right? So return the max plus 1 of it. Right. Return n plus 1 of it, right? Okay, now how do I do that? Okay, it's about iterating over all the children. So I've written not exactly as a C program, but as an algorithm which you can understand. So I'm going to iterate over I equal to 0 to the number of children, and I'm going to find out. So I have a variable m which stores the maximum height found till now. So initially I set that variable default value to 0, and then I check whether the height of child I, is it greater than m or not. Okay, if the height of child I is greater than m becomes equal to that child. Otherwise, what is the current maximum value that is stored? That's all. So m is equal to max of m comma height of I, and that gives you the maximum value to m, and then finally I return m plus 1. This gives me the height of a node recursively. Again, you need to think about, you need to convince yourself that this is correct. Okay, and we know how to check whether a recursive function is correct or not. And what was the check? The check was that you first check whether the base case is correct, and that's correct. Then you're going to assume that the recursive step is correct. So the height of child I return, that's correct. You're going to assume that. Now if you assume that, is the recursive step correct? Right? So using that assumption, you can argue that the recursive step is correct because it's returning m plus 1, right? So that's, therefore this is correct. So you need to convince yourself that if you go along this logic, the height returned is correct. Okay, so clear? Right. So this way you have argued that you have given a recursive algorithm to find the height of a node. Good. Thank you.